discussed about reaction of metals and non-metals with water and metals and non-metals with oxygen. Today, we will be discussing another two important chemical properties of metals and non-metals. So just to recall, these were the reactions of metals and non-metals with oxygen. So metals react with oxygen to form basic metal oxides, and non-metals react with oxygen to form acidic non-metallic oxides. So, and metals, they react with water certainly, but few metals react very quick and few metals react in a slow manner, and non-metals, they do not react with water at all. And when we speak about sodium is highly reactive, and that is why it is stored under kerosene. Phosphorus is also highly reactive to the atmospheric oxygen. So to keep phosphorus away from atmospheric oxygen, we store phosphorus in water. Okay, so today we will be discussing about one of the most important chemical properties of metal and non-metal, that is the displacement reaction. So what is a displacement reaction here? The name itself indicates displacement. So the placement of the metal is changed. Say, let us take an example of copper sulfate. Say, what I have done, this is an activity which is described in your textbook also, and you have done this activity the previous year as well in 7th standard, if I'm not wrong. But if you have not done, once the physical classrooms will start, I will definitely try to show you the things. Okay, or one fine day I will make the videos with all my experimental setup, and I'll record it for you guys. So for now, what I have done here is we have taken 5 beakers labeled as A, B, C, D, and E. So the first beaker, it contains copper sulfate solution that is blue in color, and I have added zinc granules to that. And the second beaker contains copper sulfate solution. Again, I have added iron fillings to it, or iron nail to it. And the third beaker contains zinc sulfate, and I'm adding copper turnings to it. Copper turnings is copper wires, small copper wires. And the fourth beaker has iron sulfate, and I have added copper turnings to it. And the fifth beaker, it has zinc sulfate, and I'm adding iron nail to it. So I will let it aside for some time. Maybe after 5-6 hours, I will see the observation, what all the observations I see. See, in the first beaker, what happens, the blue color of the copper sulfate has already gone. It has become a colorless solution, and I see a reddish colored copper settled at the bottom. And similarly, in the second beaker, the blue color of the copper sulfate has gone, and it is greenish, yellowish green color. The solution is yellowish green color, and there is a settlement of copper at the bottom. And in the third, fourth, and fifth beakers, there is no reaction seen. So now in the first and second beaker, what has actually happened there? So here, what is happening is I've added zinc granules to the copper sulfate solution, right? So the zinc granules are displacing copper from copper sulfate solution. Andre copper sulfate aliro copper na remove maadi. In that place, what is happening? The zinc is going and attaching with the sulfate ions. So now the colorless solution is zinc sulfate, and pure copper is displaced at the bottom as a precipitate. So it is displacing, copper is taking the place, zinc is taking the place of copper. Zinc is displacing from one position to other position. That is why it is displacement reaction. Similarly, in the second beaker also, the iron nail, it is displacing, the iron in the iron nail is displacing copper from the copper sulfate solution. That is why copper is settled as a precipitate at the bottom, and iron sulfate, that is ferrous sulfate, is formed, which is greenish, yellowish green in color. Okay, so it is pale green color. If this is the case, if copper is being displaced by zinc granules from copper sulfate solution, and zinc granule is displacing copper from copper sulfate solution, it should also be true that from zinc sulfate, copper should be displacing zinc, correct? ಸೊ ಜಿಂಕ್ ಸಲ್ಫೇಟ್ ಅಲ್ಲಿರೋ ಜಿಂಕು ಕೆಳಗಡೆ ಬಂದು ಸೆಟಲ್ ಆಗಿ ಕಾಪರ್ ಸಲ್ಫೇಟ್ ಬ್ಲೂ ಕಲರ್ ಆಗಬೇಕಾಗಿತ್ತು ಇನ್ ದ ಥರ್ಡ್ beaker, if this is the analogy. But why it is not happening? And in the fourth beaker also there is no reaction. Iron, sulfate and copper turnings are added together. So copper is not displacing iron. Copper is not displacing zinc also. And iron is not displacing zinc in case of the third one. Sorry, fifth one. Right? So why is this? Because there is an order of reactivity as per the theories and as per the research what scientists have conducted. Zinc is more reactive than copper. Zinc is more reactive than copper. That is why zinc can displace copper from copper sulfate solution, but copper is less reactive than zinc. So copper cannot displace zinc from zinc sulfate solution. So only more reactive element can displace a less reactive element from a solution, in the aqueous state. But a less reactive element cannot displace the more reactive element. That is why copper is not displacing zinc in zinc from zinc sulfate solution, and copper is not displacing iron from iron sulfate solution, and copper is not displacing, sorry, iron is not displacing zinc from zinc sulfate solution. So now with this experiment we should be able to derive the order of reactivity. So which is more reactive, which is less reactive, anta we should be able to derive. So which is more reactive according to you? Now I will just insert a text box. Okay, fine, I got it. So yeah, so zinc is more reactive. See, zinc is displacing copper from copper sulfate solution. It is displacing iron, sorry, so iron is displacing copper from copper sulfate solution, and zinc is also displacing copper from copper sulfate solution. So zinc is highly reactive now. Why I am telling zinc is highly reactive? Because iron is not displacing zinc from zinc sulfate solution. Andre zinc is more reactive ಅಂತ ಅರ್ಥ. Iron is less reactive. That is why it is not able to displace zinc from zinc sulfate solution. So zinc is highly reactive. And coming to the next one, iron is less reactive than zinc, and copper is least reactive. Copper is the last of the order. Okay, this is the order of reactivity. And this is all about displacement reaction. If you have any questions, you can ask me in the WhatsApp group. And after displacement reaction, another chemical property of metals and non-metals what we have to study is reaction of metals and non-metals with acids and bases. Okay, so metals, they react with acids and bases or not. So first we will take non-metals again. Non-metals, why I'm taking non-metals? Because non-metals, they do not react with acids and bases. Okay, non-metals, they never react with acids or bases. But what about metals? Yes, metals will react with acids and bases. I would just like to ask you a question. What is pop-up sound? What do you mean by pop-up sound? Pop-up sound is indication of hydrogen, so liberation of hydrogen. So pop-up sound indicates the liberation of hydrogen. Okay, non-metals, they do not react with acids, but they do react with bases. Okay, but the reaction of non-metals with bases is very complex. So it is very complex. It is not so important for you guys right now. So if you will take chemistry in your higher grades, definitely you will learn about the reaction of non-metals with bases. Okay, so reaction with bases is complex. Okay, now speaking about the metals, metals will react with acids. Okay, they will give out hydrogen gas, they will liberate hydrogen gas. And similarly, metals will react with bases also and they liberate hydrogen gas. So this hydrogen gas is the reason for pop-up sound. So when hydrogen gas is liberated in a test tube and I close my test tube mouth with my thumb, and when I bring a matchstick near to the test tube, the mouth, there is a pop-up sound because of the liberation of hydrogen gas. I assume that you people have done these experiments. If you have not done, definitely when physical classrooms will start, I'll try to show you these things. Okay, so few metals. See, non-metals generally they do not react with acids. I've already told you. Metals react with acids and produce hydrogen gas that burns with a pop-up sound. And you must have noticed that copper does not react with dilute hydrochloric acid even on heating. Why copper will not react with dilute hydrochloric acid even on heating? Because the acid is dilute, but it will react with sulfuric acid, copper. Why copper will not react with hydrochloric acid and it will react with sulfuric acid? Because hydrochloric acid is a weak acid, sulfuric acid is a strong acid. When compared, when in the reactivity series, hydrochloric acid has the least reactivity and sulfuric acid is a strong one. Okay. This is all about the chemical properties of metals and non-metals, and we have a few uses of metals and non-metals which we will be studying in the next slide.